Welcome to AI-Biotech-Studio. I'm Bruno, and today we're exploring the quantification of the carbon footprint of computation, an essential topic for sustainable technology. Well, we all think about the carbon footprint of things like getting on a plane or boat. But what about something less tangible, like running some code or maybe training a big AI model? We anticipate some of it in a way, but prepare for a bit of a shock. It turns out computation has this huge environmental impact, often totally flying under the radar. We're talking data centers, high performance computing. The estimates are around 100 megatons of CO2 emissions per year. Get this, that's roughly the same level as emissions from all of American commercial aviation combined. That's exactly why we're digging into this particular paper today. It introduces this new framework, a tool actually, called green algorithms, designed specifically to estimate that impact. It looks at the basics, the kind of hardware you're using, processors, memory, that sort of thing. And, of course, how long your computation actually runs for. Of course, a massive chunk of the footprint depends on factors kind of outside your code itself. Like a huge one is where the data center is located. That number varies wildly across the globe. And there's another layer, the data center's own efficiency. That's measured by something called power usage, effectiveness, or PUE. It's basically a ratio. Total energy the facility uses divided by the energy used by the computing equipments. A perfect score is 1.0, but most centers aren't perfect, not even close. The paper also tries to quantify some common intensive tasks, like big simulations or something very relevant now, training large AI models. They estimated it generated over 7,000 grams of carbon dioxide equivalent. And that leads to another key idea in the paper, the pragmatic scaling factor, or PSF. It basically acknowledges that in research, you almost never run something just once. You run it again and again and again. Hundreds, maybe thousands of times sometimes. So they applied a pretty conservative PSF of 100 to that large language model training example. The estimated carbon footprint jumped to over 75 million grams of carbon dioxide equivalent, something like 130 one-way flights from New York to San Francisco. But what can people actually do? The paper lays out a few key strategies. First, optimizing your code, not just for speed, but also think about memory allocation. Try to reduce unnecessary runs. Maybe better debugging, testing ideas on smaller data first, that kind of thing. And third, be really strategic about where you run your computations. Some cloud providers are starting to highlight greener regions. So, wrapping this up, what's the big takeaway? Well, it's clear that computation has a significant environmental cost, a cost we can now measure much more clearly thanks to tools like green algorithms. The final thought to leave you with is this. Now that quantifying this impact is getting easier, how might understanding your own computational footprint actually change your approach next time you build or train or run something computationally intensive? I hope this short review offered something valuable to reflect on. Until next time, take care.